Welcome all. Let's get started here. Nivedita, over to you.
Okay. So, hi everyone. Myself Nivedita Suresh. I'm a AI researcher from LLT Technology and Services. I have been working on GenAI from past 6 to 7 months right now, and I have made use of a lot of GenAI based large language models and the frameworks and everything. So today I'll be presenting a webinar on LlamaIndex, one of the framework that is used for the large language model. And I'll give a brief introduction. I mean, these are the contents that I'll be covering here. I'll explain about LLMs and various framework that I use, and we'll jump into the Llama Index and what and all the facilities provided by the Llama Index, such as data loading, indexing, retrieval, querying. This information I'll be explaining, and there are some code snippets also, which I'll go through it for the better understanding of the concept. So, firstly, coming to the large language, from the year 2017, the time when Transformer was started till now, there's a boom in the large language nowadays, where in the 2018, when the GPT was first introduced, there till now, we can see a lot of high larger language model with a heavy billion parameters and everything. So recently, the most trending one was the Mistral, and now even the multi-models have come into picture where they leverage the images, audio, and also text together, and we can make use of those languages to do many tasks, such as some of the NLP tasks, such as like inferencing or such as reasoning task, and a lot of things. So the main issue when it comes to large language, I wouldn't say an issue, but what one way is where how could we use this large language model? And if there's any new data, how can we make use of the new data to use that in a large language model? So as we know, large language model are trained on a huge amount of data, which are open sourced, some can be like domain specific, and it will be up to date. But what if like now a new data comes into a picture, and how will the language model will understand that new data? So that is where there are a lot of frameworks that have come into picture, and those frameworks help the large language models to leverage those upcoming new data and help them to understand those data and do the task on that. So here are some of the various large language model framework that are present, which was first started with LangChain. LangChain was first started in October 2022. It is MIT licensed, and it was the first framework that was introduced after once the ChatGPT had come in. And with the help of LangChain, what we can do is we can connect the large language model with the prompt and also the different data source, and we can chain it all together and build an application with that framework. That flexibility LangChain has provided. So similarly, in the same line, the another framework that had come into picture was a large Llama index, and Llama index was initially called as the GPT index. So Llama index was like a go-to platform where the LLMs could be able to understand any kind of data, any customized form of data, and it kind of provided a facility to like store these data and the embeddings, which I'll be talking later on. So that is what LlamaIndex has been popular with. And it was mainly introduced in Jan 2023. And it is an MIT license, being that we can use it for our enterprises uses and also for the research purpose. So that is one of the framework. And next is a LangDoc. LangDoc comes into the same family of LangChain and LlamaIndex, but the only thing is it's more of a enterprise use. It's not an open sourced one. But LangDoc helps for the developer in a complete developing life cycle. So he can build an application, he can evaluate and also do the processing, like the maintaining of the complete cycle. LangDoc helps in it, but it's more of a subscription based thing. And another one is the recent one, that is the Flowerwise AI. Flowerwise AI is this framework was mainly introduced for the people who doesn't have that much background with the coding and stuff. So what they can do is they can create a flow charts. They can drag drop the customized uh, sections, and they can connect it. And by connecting, we can just use that for any purpose that they want to. So it had made easier for non-coders to use the Flowwise AI, and that is actually Apache license. So which means we can use it for our research and also for the enterprise purpose. So these are some of the like the present large language model framework, and in that I'll be going into the Llama index. one of the framework. So Llama Index was initially started, as I said, as a GPT index, and Llama Index main use is, or the reason why we use is, it is very much helpful with the information retrieval thing. So what exactly information retrieval is when we get a different kind of data or a new set of data, and we want to make use of that data for the LLM. We can't put all the data all together to the LLM. So we need some mechanism where we can make use of certain data which is relevant, and then use only that data. So that is where LlamaIndex come into picture, where it provides us, like, we can load any kind of data, and it also gives us the flexibility to choose any kind of indexings and everything. And with that, we can make use of it for the information retrieval. And there are a lot of applications where the LlamaIndex can be used, such as like the question answering chatbots. And if we can use for the synthesis data generation using that knowledge agent and all these things. So there are a lot of places where the LlamaIndex have been used, and LlamaIndex provides mainly the four services. One is the loading, second is the indexing, third querying, and fourth is the evaluating. These four are the main services that are provided by the LlamaIndex. I'll be going through one by one, all of those. So here I got a GIF from the internet. So here this GIF tells us the two phases of the LlamaIndex. One is the indexing phase and the querying phase. So as we can see here, so initially, when we are putting a document here, the documents are passed to a document loader. Document loader is one of the services that is provided by the LlamaIndex. And from that document loader, they are created as a chunks. And these chunks are next put into an embedding model. And this process is called as like the indexing process. And this indexes will be then stored in the vector database. So we have the document which will be in a vector format here. So whenever we are doing the query, so here we are asking a question here, and the question is converted into an embedding, and that embedding along with the embeddings of the vector database, we will be able to find which is the similar chunk that is more suitable for the question, and that chunk will be passed here, and little bit of pre-processing will be done, and the output will be then given to the user. So as here we are saying that there is a David resume that is being passed, and the query they're asking that where did the David has done his masters. So rather than going through the complete document, the LlamaIndex will say, with the help of Llama indexing processing uh, facility, it says that he has done his university from Hamburg. So this way, the LlamaIndex helps us in the document retrieval process. And I'll be going and explaining each and every steps now. So the first step was the data loading step. So data loading is the initial phase where when we are creating any machine learning model in the initial state, it's like we do the pre-processing, we do some of the feature engineering, and then only we pass it to the model. So that is what the data loading does. So data loading is like the first stage of the Llama index, where it takes the all kind of data. As you can see in the picture, it takes like a presentation, PDF, and SQL, and also like unstructured data that has YouTube and all the kind of data, and that will be passed into LlamaIndex. And LlamaIndex provides us a flexibility to use all this kind of data without having a lot of things to code with. And with simple few steps, we can use those information, and that information will be converted into a readable data for the LLMs. So that interface the LlamaIndex is providing. And there are many data connectors which are also called as data readers, and these data readers can read any kind of data, and that data will be then passed for the next process. So now the first phase is the data loader, and what happens after data has been loaded into llama index. So once the data has been loaded into llama index, there are one of the way which LlamaIndex provide is a simple directory reader. So what happens is we can have a folder and we can have a lot of document in it, and it can be of any format. So I don't have to say that this is a PPT document, this is a PDF document. I can only pass that folder in which the data is present, and the LLM LlamaIndex has the ability to understand what kind of data it is, and it accordingly internally process those kind of data. And the first thing what LlamaIndex does is, once it takes the data, it breaks the data into nodes. So nodes could be quite confusing. Nodes are nothing but we have like a 5 to 10 pages of a PDF, and we can't pass all the data to the LLM. So we need a mechanism where we can reduce the context size and use that for the LLM. So that is where the whole document will be broken into nodes. Nodes are nothing but way of splitting the document in a smaller chunk, and then using that chunk for the next process. So LlamaIndex has a multiple text splitting process. So one is the simple node parser. That is a default text splitting process. So what happens in the simple node parser is, so when we pass a document, it considers the default value of 1024 token, and that much of token will be set for the complete document. So like 1024 chunk of data will be like splitted, and that will be considered as the node. That is the default simple node parser technique in the LlamaIndex. Second is the sentence splitter. So where the document will be splitted into multiple sentences, and we can also give a restriction on it should be till a comma or it should be till a full stop or some special characters. We can give that flexibility here, and till there that boundary region, until there the chunks are created. Then next is the sentence window parser. Sentence window parser is more like the slider window as such. So it moves, if we give a window size, it moves in that according. And what happens is it also contains the metadata of the previous neighboring window as well. So it kind of considers some informations which are in the next 2 to 3 window data that will be added as well. So that is the sentence window node parser. Then is the semantic split node parser. Semantic split node parser is the only splitting technique where the embedding models are used. So embedding models are like from the LLMs where they provide a facility to convert the tokens to the embeddings. And based on the embedding similarities, the tokens are split. That is where the semantic split node parser comes in. And the next is the token text splitter. As the name says, we can specify how much token size we needed, and based on that, the tokens are then broken down, and those will be considered as the nodes. So I actually have a code which can explain these concepts in a better way. So I'll just go through it. Okay. So initially, before starting with the node parser, the LLMs, LlamaIndex has a facility where we can make use of multiple LLMs altogether. So here I have given some of the code snippets where how we can make use of OpenAI, how we can make use of Gemini, and also the Hugging Face models altogether. So here, if we are stuck with any of the place, there is one website called as Llama Hub. So this is a contributor website for LlamaIndex. Here, when we look, this is the official pages of official contributor page for Llama Hub. So if I'm looking for any LLMs I want to use, I can just go to that LLM like tab here, and I'll get a list of options that the LlamaIndex supports. And if I want to use this Mistral AI, I'll get the which installation I have to make for that package and how I can use call that in the library. And using that, I can use the LLM models. So that is what I have done here. So I have installed right now I'll be making use of Gemini API key. So the Gemini model, in order to use it, I have to use this particular importing library. And with that, I can call the Gemini model here and ask a query here. So right now I'm not doing any RAG method here. I'm just simply using a LLM model and then asking it some questions. So that in that way we can make use for the OpenAI and also like the various Hugging Face model here. So one more thing is here, when we talk about LlamaIndex, it has a default setting for OpenAI. So whenever we are running a LLM or whenever we are using a Llama index, so when we are using any query, it default takes the OpenAI. So we should be able to set that later. I'll just go through the code later, where we have to change the LLMs we want or the embeddings we want. We can make that changes accordingly and use it. So coming to the node parsing techniques, just a minute. Yeah. Currently, I'm taking a simple directory reader, which I said about. So from here, I can take a directory where the data is present. Right now, the data that I am using is in the LlamaIndex data folder, which consists of two PDF. One is about the transformer model, and another is about the current, like whatever the news recently done. So first, I'll be considering the simple node parser. So this is the library that I have to use for the simple node parser. And when I pass the document and say that use the simple node parser, this is how the checking
Nivedita,
happens. Yeah,
what is the meaning of node here?
yeah. So node actually means, so I'll just open the file. So this is the file. As you can see, it is a 15 pages file. Okay. So now I can't put the complete file to LLM. So in that case, what I'll be doing is I'll be breaking this whole data into a chunk format. Like this one page could be like a one chunk and the other page could be one chunk. So that chunk is what we call it as node in the Llama index. Hope that's clear. Okay. So the process of creating nodes, there are multiple ways where Llama Index provides us a multiple properties create the chunks, various techniques for this node creation. The first is the default one, that is the simple node parser. So simple node parser with default, it takes like a 1024 chunk size. So right now when I do the chunking, the first node consists of like the complete information till one page, and the second node consists the information till second page. Here I have the flexibility where I can mention what is the chunk size I need here and what is the chunk overlap if we need all this information, like the extra information we can pass and do it. Currently, I've kept the default one. So default one, this is the first node that it represents us. And second, so yeah, here I can't see the complete node. So here I can see the node ID for that document. So this is the first node ID and what is the text given for it. So it starts with the provide proper attribution. So if you go here, the provide proper attribution comes here. So the first thing here. And the second node starts with one introduction to recurrent neural network. So that comes here. One introduction to recurrent neural network. So till here, the first node was considered. And from here, the second node was considered. Like that, the nodes are being splitted in the first splitting technique. And next is a sentence splitter. So sentence splitter is almost similar to the node parser. The only thing is we have the flexibility where we can say to which sentence we have to, like we can give the paragraph separator or we can even give the secondary chunking rejects. We can say that till these commas or exclamatory marks, you have to split it. So those kind of flexibility the sentence splitter gives us. So here also the same checking has happened, how I said. So the first node is taken from here till the first page, and the second node is taken from the second page. So that is about the sentence splitter. And next is a sentence window parser. So this is another technique which is almost similar to sentence window, but here, rather than leaving out the neighboring data, we will also consider the neighboring data as a metadata path in our nodes. So what happens is, yeah. So till here, first window will start from the proper till this entirely. So this is the first node that is considered. And when it comes to the second node, it starts from attention is all you need till the train. So which means when it's like a window size that is kept. So every time it moves with the chunk size mentioned, and with that the nodes are being created. So like that, for the second node, it starts from attention is all you need until tree. So this is how the second nodes are created. And if you go for the third node, it can start from the domain and then it can go till the last page. Like that, the window keeps moving. Based on the window movement, the the nodes will be created here. And this is one of the techniques. And next one is the token text splitter. Token text splitter is here we are going to specify the chunk size in what chunk size it has to be, and based on that that amount of chunk will be used. Right now I have said that chunk size should be 300, and that's why from the whole page it has taken from here to here, which is approximately the 300 tokens, and that tokens only will be the first node, and then the next 300 tokens will be the second node. That way the tokens text splitter helps in breaking the whole document into a different tokens. And the next another technique is the yeah. The another node is a hierarchical node parser. So this is more like a tree structured based noding. So what we can say is we give a chunk size. So we will have the chunk size in three form and it should be in a decreasing order. So first I've given 2048 as the first chunk size and the 5 and 2 as the second and 128 as the third. So what happens is it first breaks the document into 2048 as the first chunk. Inside that, it will make a subdivision of the chunk with the 5 and 2, and inside that a subdivision of 128 chunk is done. So as we can see here, this is one complete starting division, 2048 till here. And second division is between 5 and 2. So it may consider from here to somewhere around training data. That will be the second division. And the third division was 128. So it started from the providing proper till here. So, and like that, the in a hierarchical way, the chunks will be created. So that is about the hierarchical node parsing, and it's how the nodes are being treated in hierarchical node parsing. And the next is a semantic node parser. This is the only node parsers where we will be using a embedding model. So based on the embedding and that semantic in understanding, the nodes are being split. So as we can see here, based on the embedding, it has considered from provided till here as one complete node, and then it has considered the next paragraph as a second node. And similarly, the third paragraph. So here the chunk size is not it's not constant. It varies actually. So here the first chunk is bigger and the second chunk is smaller. Second node chunk is smaller. And when we go for the third node, it depends with the semantical way. So based on that, here the chunks are created. It gives a better understanding of the nodes, and this is most preferably used in nowadays. So this is all about the node parsing.
I had a
You can,
question.
yeah,
How is the semantic thing done? Like, how does the model determine the chunk size from the embedding model?
yeah. So embedding model right now it goes with OpenAI embeddings or Hugging Face, or even right now I'm using the Gemini embedding. So based on its understanding, like the semantic understanding, it first breaks the document. I mean breaks the chunk, and it limits to till where that semantic understanding is present. Like for example, if we go for the first chunk, the first paragraph is talking about the abstract, which is more relevant to the abstract part. So it semantically understands that till here, we can consider that as a chunk. And coming to the something below, it is taking a different information, like the semantically talking about the different information. So it considered that as a another chunk. So basically, based on the embedding model that you will be using, the semantic understanding varies.
So does it first split into chunks and then calculate the similarity score between the chunks and then decide on what chunk where to like split the document? Does it work that way?
Particularly, the internal working of it is not mentioned anywhere, but usually when we are doing the embedding, that's the process we follow, where the whole data will be like broken into smaller chunks, and then between the two chunks, how much similarity they are, like how related they are, that will be considered. So yeah, that could be a way it is done. And if you take like till abstract, I think the whole information talks about the like there is a linking also, like how it started, and everything is linked to the concept. So that's the reason it might have considered that this embedding will be a part, it will be a one single entity, and then the next part.
Okay, thank you.
Yeah. Okay. So this is the node creation technique. And next is the once the nodes are created, we will be converting that as an embedding model or the embeddings. And so what exactly embedding is so LLMs are mainly a mathematical computation. It can't understand what the text is all about. So it is important for any text to be converted as a numerical format, and that numerical format will is called like the conversion of that process is called as indexing. So now we have the nodes. Nodes will be like a chunk, and that chunk has to be converted into an index format. So as you can see, here is a text that tells about show me the Boston ground transportation. So this statement is converted into a numerical vector format. So it has, this is the one vector for that. So here we have like a multiple statement, and for each statement, such a embeddings are created. And based on this embeddings, they will, if we plot it on a graph, as we can see, anything related to ticket fare will form like a one cluster or like form in the same part, and anything related to airlines they are forming here, like these are the information that are talking about airline. So like as you can see, there's like a division from here to here like a ticket, and from here to here it's about the airline, and whatever about the ground transportation are coming here. So suppose if I want to know about the fare of the ticket. So I'll send a query that what is the fare of the ticket, and fare is one of the word when it converted as an embedding will have the similar score when compared to the round trip first class ticket. So as a class ticket is talking about the money, and also the business fare is also talking about the amount. So there is a high possibility that this sentence may usually be the one needed for the query. So that's how the embedding works here. And here we are taking sentence, but in the LlamaIndex, we're considering them as the nodes. And LlamaIndex,
How is this logic derived on like how the text is converted into embedding? Those are the numbers, right? So
mhm.
what is the transformation happen? What kind of is it alphabet to number format, or is based on the aggregate function on overall word? How is that generating that number?
Yeah. So basically, when there are multiple embedding techniques actually, so one of them is the word to vec technique. So what happens is the complete word will be converted into a vector format, and for the conversion of it, it basically goes with the similarity, like how I'll say, okay. Um, So if we take like a king, queen, and women, men. So king and men are the if we create a vectors out of those things. So king and man will have the similar score because his king is like of male gender and the man, and they both will be given a score, and this the score that will be created will be similar. So it's actually the internal working of the word to vec. I don't have a like complete detailed information on that, but yeah, I can get back with that information. But that's how that is one of the techniques where the text is where we convert the word to a vector format and use that as the embedding.
Nivedita, this is Narasimhan. In my use case, I am planning to do the custom embedding techniques for my domain specific. Could you have any example for the custom embedding, how to integrate and like that?
Well, for the custom embedding, yeah, LlamaIndex has that facility where you can create your own custom embedding techniques.
Okay. Could
Yeah,
you have any example for that in your slide?
I don't have it in my slide, but there is a
Yeah, I've seen the API they're providing, but I'm expecting some examples or any. That's why.
okay. In my slide, I don't have it, but I can share you some resources that are related to that.
Okay. No issues.
Yeah.
If you have any, you can share.
We can use Pinecone, VB8, Roma, AWS OpenSource. These are popular embedding APIs or libraries which can embed
Yeah.
custom literature which a company or individual might have. So I guess that's what you're referring to. So popular embedding, libraries will embed or vectorize or mathematically represent the data you might have from your company or your personal projects.
Okay. Yeah, got
Uh,
it.
yeah, Bhavin here. So what are the what is the advantage of using this custom embedding, and why not the ones that is already available?
Um,
No,
okay,
I
so
suspect
Hello.
he meant custom literature, not custom embedding per se. So my suspicion is it was reference to a specific corporate literature being embedded, but using
Okay.
embedding architecture.
Okay.
That's what
Okay.
I'm guessing. If it is different, then Narasimhan can comment.
Sorry, Narsima, can you please repeat?
Bhavan, for my use case, there is no sequential information. Okay, I'm handling that. So I don't want need any BERT or any hacking phase embedding because they are pre-trained with the sequential informations on that. But my in a scenario, there is no sequential information. Just trying to extract the what are the information or insights from the sum of the text kind of thing. That's why I using planning to get a custom attack. Bhavan.
Got it. Got it. Thanks, Narsima. This is good. Yeah.
Yeah. Thanks, Bhavan. Yeah. Thanks, Vivek. Thanks for your answer. Anita, you can go ahead.
yeah, okay. So LlamaIndex has some of the various embedding techniques as together. So in that, I am like explaining about the four different techniques and how they'll be useful for our next if you are using any information retrieval. So the first is the list index. So the list index is a simple sequencing of the index, like where we have all the nodes and they will be connected in the list format. And based when we ask a query, it will go with the like most if I ask something about the population, it checks where the population word is mostly present. If it is present in a node 2, it consider the if it give like similarity search of 2 or like that, it will take the next two nodes and that will be passed to the response synthesis. Response synthesis is the place where the query and the response synthesis data that is taken from the node will be then converted into an embed and then it will be converted into a normal like the in a format and embed and that will be passed for the LLM and the LLM will make use of the node data and also the data that the query has given and based on that it will generate the answer. So that is where the node list index comes into picture. And coming to the vector store index is the most commonly used one in the llama index. It's almost similar to the list index, but the only difference is in the list index when we are creating the indexes we are not converting that to an embed. The embedding happens only at the time when the response request or the query is happening. Whereas in vector store, when we are creating a node, with that node only the respective embeddings are already created. And that's how they will be stored in a one complete this structure. And when we give a query, based on the query, here is what similarity search happens, where the query will also be converted into an embed. And based on the most similar match, those two nodes or any multiple nodes will be then passed to the response synthesis. And that node, along with the query, will be passed to the LLM. Based on our whatever the task we have mentioned, the output will be formulated. So that is the difference between the list index and the vector store index. The another kind of indexing is called as a tree indexing. So it's mainly a top bottom up approach. What happens is we have like a multiple nodes here, and for each node there is a parent node that is created, which consists the summary of node 1 and node 2. And similarly, the node 3 node 4 summary will be converted as a parent node, and this process will happen until a one single root node is created. So once the root node is created, this whole structure will be used. And here also the embedding does not happen when we are doing the indexing. Embedding happens only after the querying process. So when we pass a query here, the default one is like child branch. There's one factor which called as a child branch factor. The default one is the one child branch factor. The query passes to the root node, and one in the root node, it will then go to the one node, that is the one child node below that, which is relevant to the query. And based on the query, it will again go down to the node in which the query is present exactly, and that will be passed for the response synthesis, and that can be used for the final embedding, and then that can be used with the LLM to give the final response. Whereas there is another concept called as child branch factor 2. What happens is it takes the two branching nodes in the every step. So when I say the query goes to the root 1, and then it considers the parent node 1 and the second parent node 2. If it was the third node, it would have only considered the two nodes. And then coming down, there are like four nodes. From the four node, it has to consider only two nodes. So it will consider parent node 1, say the node which is more relevant, and parent node 2 say which is more relevant. And that will pass to the response synthesis. And that will be then passed with the query to the LLM to give the desired response.
I had a question on this. Does the tree index work on any splitter, or the hierarchical splitter is needed for the tree index to work?
So right now here, it's not the hierarchical splitting that happens. It's actually the summarizing that is happening. So it takes the two nodes. It can take any splitter. Like it can even take the token splitter of two tokens, and those summary will be then passed to the parent. So here there is no restriction that it should be a hierarchical splitter.
Okay.
Yeah. Okay. So the another one is the keyword based node creation. So what happens is whenever the nodes are created, from each node, the most common keywords are extracted first. So like, for example, the node 1, the most common keyword would be New York and city. Node 2, it could be population. Node 3 could be like the climate and politics. So these keywords will be then again mapped with the nodes, like where these keywords are commonly present. Like suppose the node 1 and node 2 could be talking about a city itself. So the city keyword will be linked with the node 1, and again the city will be then again linked with the node 2. Like that, all the keywords, wherever the node they are, it is connected. So what happens is whenever a query comes in, the query will be converted into a keyword, and with those keywords, whichever the matching keywords are present, that keyword to which node it is linked. Like for example, I'm talking about what is the climate of New York City. It will take the New York City and the climate as the keyword from the query, and it will map with the keywords that are present in the node keyword mapping. So usually the mapping is present. So these keywords will be mapped to the respective node. So it will find the New York is one of the keyword from the query. It will map to the node that is present here, and it will take that for the response synthesis. And climate is also one of the keywords. So that will be passed for the node 3, and that will be passed as a response synthesis. So based on that, the nodes will be then used as an embedding, and based on the query and LLM, it gives the desired result which is required. So this is about some of the indexing techniques that LlamaIndex has provided. If you have any queries here.
Nivedita, so I'm familiar with, let's say, VB8 embedding or Pinecone. So if you are using LlamaIndex, how will indexing by LlamaIndex work in conjunction with, let's say, Pinecone embeddings?
Okay.
So will we use LlamaIndex as a data integration layer and then still store the embeddings in Pinecone or VB8, or we don't need Pinecone or VV8 if we are using
No, we need that actually. There is a concept called vector storing in LlamaIndex, where
right.
once we have the indexes, we can either store it in our local, or if the data is useful, we may have to store it in those embedding vector store, like the one who provides us that facility.
So LlamaIndex is not having a vector storage, correct?
Yeah, they're not having the dedicated one for themselves.
Now,
So we
when we
need
are
a.
using LangChain with VV8,
Mhm.
we didn't use LlamaIndex. So then who was doing the job of indexing there?
So
I
the
mean, I
index,
don't know. I mean, I'm just asking how developers do it.
maybe I have a code here, maybe that could give you some information how it happens.
Because we use LangChain mostly so far, not LlamaIndex.
Mhm.
So then who was playing the role of indexer?
Okay, that's what, like here for the indexing thing. Okay, let me just go directly to the code with you. Yeah,
Because I'm not coding, my team is. So that's why
yeah,
I
yeah.
didn't get that.
Okay.
We're doing a lot of LangChain work actually with
Um,
VV8 embedding.
but actually, LangChain is the one that's been most commonly used now. Like, see, it gives like a better, what do I say? Easy plug and play things. Whereas LlamaIndex is mainly for this data ingestions and how we can break them into monodes and then the indices thing that happens. But even after indices has happened, the indices has to be stored in certain place. So that's where this Pinecone or any other vector store comes in. So where you can store this indexing that happened there and use it whenever needed. So internally, how that happening, maybe with the code I can say. So it's the same documents that I'm passing here. And first step is the node creation. Here we can either create our nodes or we can directly use the document for the query. So what happens is here I'm just using a simple node parser and creating the nodes for this parser for this document. And that node we'll be calling the vector store index, which is a LlamaIndex vector store index, and we'll be passing the document. We'll get the indexes here. So this has been done by the LlamaIndex internally. And with this index, we can convert that as a query engine here. And this will be converted as a query engine. And then we can use that query engine to ask any questions here. So I can say that what is a transformer? Based on the indexes or the value, it will give me the response that the transformer is like its architecture for the full self attentions like that. This is how a Llama indexing, the whole process works altogether. And when it comes to Pinecone that you mentioned, so we have a new index here. So every time we are running, it creates again. No? So we don't want it to be created again. So we use those vector stores to store this index rather than using them to create an index. Okay.
One question. So this indexing technique have any relation to like vector database, or they are independent? I mean, any indexing technique can be used for vector database.
Yeah, it's independent of the vector database. It's not like you have to use. So you can make use of pre-indexing also. You can make use that index for the vector database. It's completely independent.
Okay.
Yeah. So there's two ways actually. One is with the node based where you can call the index. And second one is you can directly pass it. So vector store index, I can create from the document itself and I'll directly pass the document. The default, whatever the node is there, it will create and that index will be generated. So this is for the node based result and this is for the only like direct default node based result. So here is one example where how the final responses are taken from the nodes we can see. So here we can say that these are the two nodes that it has considered. And based on that, whichever the similar information which can give the final response, it has considered from that node. So this is how the LlamaIndex actually works. Like it considers the nodes which are more similar and that indexing that happened. And based on the indexing, it says that this particular node has the relevant information and that node will be passed with the query to the LLM. And then LLM gives us the final response here. This is like a complete flow of how the LlamaIndex works on. And actually, this indexing can also be stored locally, or we can make use of any vector stores like Pinecone or Data Lake or all these things to store these indexes, and we can fetch it whenever we need it. So that flexibility is also provided by the LlamaIndex. Any queries on that?
Yeah. This one, the one that you're showcasing right now, is that based on that embedding indexing thing that?
Yeah. This is the vector store embedding.
Yeah. Before vector store, the sequential one and the one, the embedding based sequential one, both of these, do they return only one node per query, which is the most similar one, or do they return multiple the way this one returns as well?
Actually, the default one is 2. Okay, we can give that flexibility when we are creating the query engine here. We can give like what is the similarity search we want. If I want the top K, like top 2, it will take 2. If I give top 3, it will take the top 3 one. So basically, it comes in the query engine.
No matter what the underlying technique is, it does search top K based on whatever we used. Okay, understood.
Right.
Thanks.
Okay. So this is actually I wanted to try for the list index and all, but Gemini was not like matching. Gemini embedding was not mapping with it. I was getting one other error with that. So I can share the document where they have made use of all the different techniques where you can try with that. And as I go further, as I said previously, the LlamaIndex gives us a flexibility to use various type of data formats. So I'll explain like 2 to 3 formatting where which in what way they have used and how simplified way it is. So first I'm taking this URL here, which is talking about Anthropic news about it. So it's mainly a URL that is, and the LlamaIndex is giving me a data loader here, and in the data loader I'm telling about the beautiful soup reader. So beautiful soup reader is mainly used before for like if we want to have like any HTML page and if you use a beautiful soup reader, it passes through the HTML page and considers the context from the HTML page. So that will be done here, and that will be used as a loader here. So when we are giving the document to load the URL, it will take the URL and based on the beautiful soup reader, it loads it, and that information will be contained in this document. Now this document we will again do the indexing and then we do query on that. So that is what I'm doing here. So I'm creating a vector store index for this document, and then I'm asking a query that what is this web page talking about, and it gives the response that it is talking about the Cloud 3 model family and all this information. So that is how easy it is. Like we can make use of just like 4 to 5 lines to query a web page and then get the response out of it. And we also can give extra questions on like what explain more on the cloud, and it gives the information on that. So this is how the vector,
how the vector a little bit, not readable actually.
Okay, sorry.
Yeah, better, yes.
Yeah.
Now it's good.
Okay. So yeah, that's what I was telling you. It will first take the URL, and with the beautiful soup reader, it will extract the lay data from here. And the data loader from the LlamaIndex will load the URL and converts it into a document structure. And that document again will be converted as an index. That index for the query, we can ask the queries here. That's how like usually if we are using any other framework too, we have to like do this pre-processing before only. There's no like, I don't know if it is present right now, but when I was using, there was no like flexibility to use a different types of loaders altogether. And next one is the SQL based query. So first what I'm doing is I'm creating a SQL, and yeah.
In the last section, we did not mention the splitter. So it does automatically, or
yeah. So the default one is the simple node splitter.
Okay.
Yeah, which takes the chunk size of like 1024, and with that chunk it creates. If we want, we can also create a node splitter here after the document and specify what kind of node splitter I want, if it is a semantic or any kind, and then use those nodes here for the document. So here earlier,
can the nodes be splitted with the header files in the HTML?
Yeah, that flexibility is also there where you can create when you're creating this. There's a different node splitter altogether for the document where you can specify what way you want to.
Okay.
Yeah. So that's on the HTML thing, querying, and then it's a SQL based querying. So here we need the SQL alchemy, and we are create here I'm creating a basic small like a table where it has like a tornado. It has three fields as such. One is the city name, one is the population, and one is the country. So we have what is the city name, what's the population, and what is the country altogether. And then I'm creating a engine out of it. So like if I this is the SQL that is already created. If I give a query that select the cities and these are the cities, it comes in. So basically till here the SQL creation has happened. And LlamaIndex is having a flexibility to use the NLSQL table query engine. So what happens is this is more like an indexing for the SQL database where you'll pass the database and will also say that what is the table name and what is the LLM that you want to use. So now based on this query engine, I'm telling a query that you have to select the city stage from the city stat. That's like the table name. From that, you have to take the city name. Actually, we don't need to ask like this. We can ask a normal question like, can you tell me what and all are the state names present? We will get it. But since I'm using the Gemini API, since when I gave a normal question, it gave me a no response to that. So I had to curate the query this way. So query basically depends on the way how you're using LLM. If you're using an OpenAI LLM, you can ask a normal query, and based on that, you will get answers from the SQL database. So as you can see, I have asked it like what are the city names present. So it has given all the city names that are present, like the Tokyo, Chicago, Seoul, and these four things. And they have like what do I say? They are like in the decreasing order of the population. They have like given the result. Similarly, I have given like in the city and the population of the city state, it has given that the most cities and what is the population of it, and for every the city ka population have given in a more understandable way. So, and similarly, have given like what is the country in the Canada country, what is the population kind of thing. That's what the query was supposed to be. When I gave the normal query, it didn't give me the result, so I had to write the query in this way. So it has given that the most popular city in Canada is Toronto, and the population is so and so. So this is how we can have the SQL or any table structure in the SQL and use the LlamaIndex NL SQL query engine, and we can use pass any queries and get answers through it. So there was a question about how we can store the indexes in different this thing. So here it's basically for how we can store locally. So I'm just creating a folder here, telling that this is this folder, and what it does is it goes into the vector store. It creates the index, and that index will be stored in that directory. So if I go to that directory, that is D and vector storage, I'll have these default indexes here. So a default vector store, which will have the embedding, and it will have that node name. This is node ID, and what is the embedding of that. Like that, it gets stored here. Similarly, graph store, it will be empty. If we have like any graph based indexing, it will be stored. Image based, if it is there, it will go to that particular folder, and we will be using that particular indexing. So this one, rather than storing locally, if we don't have that space, we can make use of the any vector stores that are available and connect that vector store here, and then we can pass it there. So here, once the data is stored, we can use that index. So we can call that index by load from the storage. So what happens is from whatever the context storage that is there, it will load from there and gives the answer. So whenever I'm asking a query, once I have created the index, I can have that stored in my local directory. And when I'm asking query the third time or fourth time, we won't have to create the index every time. So it will be already present. You can just query it and the time will be reduced. So this way we can store the indexes. And how we can do the retrieval. So this is all about the LlamaIndex querying, there are a lot of concepts about agents and everything. They are like advanced concepts in the LlamaIndex. I try to like cover most of the concepts that are present in LlamaIndex. If a beginner want to use it, what and all things that I can use. So those things I've added here. So if you have any queries, you can ask.
So I think there were 1 or 2 questions coming on the chat.
Mm-hmm. I think you answered most of the question.
Okay, sounds good. So, friends, any other questions for Nivedita? Okay, thank you all for joining. Excellent presentation, Nivedita. Thank you for your hard work and presentation. Well done.
Thank you, Vivek, for this opportunity.
Thank you, folks, for joining. Thank you, Nivedita. We'll see you in our next webinar. We do have one more later today, 7 p.m. IST. Have a good one. And
thank you. Thank you, Nivedita.
Thank you, everyone. Thank you so much.
yeah, just a moment here.